So, a lot of books start off by saying the sun is a typical star or the sun is an ordinary star. So, what does that tell you? Well, that would suggest that stars are like the sun or the sun's like other stars, that the sun's pretty ordinary. So, the question is, what about nearby stars? Are most stars like the sun? And so, let's consider. So among the nearby stars, of course, we have the sun is the nearest star to us. The next nearest star to us is actually Alpha Centauri, Rigel Kentaurus. And it's really a triple star system. So Alpha Centauri, A and B, are these two pretty bright stars, orbit each other very close, and there's a third little dim star that orbits way out away from the rest of them around the other two. And that star is called Proxima Centauri. Well, Alpha Centauri is now, you can think of that as a triple star system in which Proxima is an M-type star, the Sun is a G2, Alpha Centauri A is a G2, and Alpha Centauri B is a K1. The next closest star to us is Barnard's star, and Barnard's star is an M-type star. The next star after that was one that was discovered by a satellite and just has a catalog numbers. And these are like failed stars, like brown dwarfs. And so next one after that is one of these Y-type stars we talked about. The next one after that is Wolf 359, another M-type star. And when I first started teaching astronomy, Wolf 359 was known as the third closest star. Those other two weren't known at that time. And so Wolf 359, the third closest star to us. And interesting thing is that historically, that's an interesting thing in fiction as well. There's several science fiction stories about Wolf 359. Many years ago, there was a science fiction show called Outer Limits that had featured Wolf 359. And in Star Trek Next Generation, Wolf 359 is where the Borg cube obliterated the Federation fleet. Next one after that, BD plus 36 degrees 2147, another M-type star. Sirius is actually a binary star in which you have an A-type star. That's the first of these stars is actually hotter than the sun. And then a dwarf A star, so a white dwarf. So now we finally have something hotter than the sun. The rest of those are way cooler. Next one after that, another binary star in which you have two stars. And then the next one after that, another one. These are all M-type stars. Next one after that's also an M-type star. Next one after that is a T-type star or brown dwarf. Next one after that is a K-type star. And so you see a pattern here. The sun is a G2. And we say the sun is an ordinary star. How ordinary is the sun? Well, not all that ordinary. There's only one other G2 in this entire list, and only one star and a white dwarf, which is a weird thing anyway, that's hotter than the sun. Everything else is cooler, much cooler. What's typical in this list? Well, M-type stars. That's the most common. The CD minus 36 degrees. It's another M-type star. In fact, if we go out to the 75 closest stars to the sun, only 5 are as hot or hotter than the sun. 13 of the 75 nearest stars are brown dwarfs. Brown dwarfs are actually failed stars, things that form like a star, but they don't ignite like a star. 2 of these are white dwarfs. There are 16 multi-star systems, 35 stars, so almost half of the nearest stars to us are part of binary systems. Sun's not a binary star. 49 of the nearest stars are M-type dwarf stars, M-type main sequence stars. So this is an interesting thing. What is the typical star? An M main sequence star. That's the most common kind of star. In fact, M-type stars make up the bulk of the stars that are out there. K stars, much less common. G stars, less common. And then you get more and more. The earlier spectral types are more and more uncommon. So the HR diagram dominates going down. What do you see? You don't see these little M stars because most of these things are too dim to be seen with the naked eye. So the stars that you see are normally these things that are up here. Even though they're not very common, they are very bright and they stand out. And so that's why you don't see the most common stars. That, well, again, what we called earlier the Malmquist bias. If you go out 10 parsecs, keep going 10 parsecs, the vast majority of the stars are M-type red dwarf stars, M-type main sequence stars. K-type stars, the next most common, okay, and then G's, and then these L's and T's and Y's and so forth down here. White dwarf stars, they're kind of odd. We'll talk about those. Those are actually dead stars. So, but of the living stars here, you know, by far the M-type stars dominate. Most of the stars that exist in the galaxy are red dwarf stars. These are tiny little stars, many of them only a few tenths the mass of the sun. Not tens of masses, but a few tenths. So a fraction of the mass of the sun. So you could fit maybe take 8 red dwarf stars and they'd weigh the same as the sun. And so they're most of the galaxy of these tiny little things out there. These hotter stars, the ones hotter than the sun, you know, only less than a dozen stars hotter than the sun within 10 parsecs. Remember 10 parsecs? That's a parsec is 3.26 light years. So 10 parsecs is 32.6 light years. So in that region of space, red dwarfs dominate.